I'm sure we'll never tire of hearing that sound. So now we're going to move on and add a couple of new features to our sound demo app. The first of which is going to be adding a volume slider. So very simply, this will be a slider that the user can manipulate up and down and change the volume of the sound within our app. Then we'll bring in a second slider which will allow the user to seek back and forth between different parts of our audio file. This will give us a chance to use the seek bar in Android, and also we'll come across the slightly mysterious override command, and I'll explain what that is when we get there. Alright then, let's get straight to it. So we're going to start by bringing in our seek bar. So we do that over in our activity main.xml, and here it is, just there. So let's drag that in just underneath the pause button, and there it is. I'm going to see if I can just enlarge that a little bit. And you can see when I drag that to the end, it picked up the align parent end tick box. So if I tick align parent start, then that will align it with the start of the parent being the relative layout. So this part here that you can see is just dotted there. Okay, so now we have our full width seek bar. I'm just going to give that an ID. Oops, by double clicking on it there. So the ID is seek bar. In fact, I'll just keep it like that. That's perfectly reasonable. Okay, so now we're going to allow us to do something with that seek bar over in our Java activity file. So before we actually integrate our seek bar into our volume control, I'm going to just see how we work with a seek bar independently of audio. So what we'll do is we'll make it so that when the user moves the seek bar, the result or the resulting value is displayed in the logs. Simple as that. So first of all, we create our seek bar variable, and to be able to use that we will of course need to import the seek bar widget. So we can do that with import android.widget.seekbar. There it is. So now we can create the seek bar variable, and I'll call it volume control, even though as yet it's not doing any volume controlling. And we're going to find that in just the same way that we found the buttons and labels earlier on in the course. So we're going to use find view by ID, and then R for resources .id to get together all the IDs, and there's my seek bar there. That by default will be a view, and we want it to be a seek bar, so we're going to need to cast it to a seek bar by putting seek bar in brackets like that. There we go, and that's still in red because it needs to be a capital B. There we go. So now we can use the volume control variable to reference the seek bar that we've created. So if we want to kind of catch the event when the user drags and takes their finger off the seek bar, what we do is we take our volume control variable and we add a seek bar change listener. So we use set on seek bar change listener. There we go. So this is a listener, so it will listen for the event that the seek bar has been changed, i.e. that the user has dragged it one way or the other. And then this will be created as a new, and then seek bar on seek bar change listener. And something's gone wrong with the auto predict there. I want that to be there. And then we're going to have a bunch of code in the middle of all of that. There we go. So what we've done there is added a seek bar change listener, and that has a type of seekbar.onSeekbarChangeListener, and then we can implement our code that we want to happen when the seekbar is changed here. And I think we just need to import the seekbar onSeekbarChangeListener to pick that up. Okay, so now there are a few possible events that could get us here. This listener will be called whenever the seekbar starts to be changed or stops being changed by the user. But we don't really care about either of those events. We want the one event when it has completely been changed. And that event is onProgressChanged. There it is. So we've got some lovely default code there that we don't have to type out, which is very handy. And the main new thing that we're seeing there is override. So this @ symbol and then override. What does that mean? Well, this onProgressChanged method that we've just created here is not a new method. It's a method that already exists. And some things within the Android system will happen every time the seekbar is changed. So what we're doing here is not creating a method, but we're adding our own code to a method that already exists. And that's when you need the override command. So in fact, we've seen it up here and here as well and here. So we've seen this override, but we haven't really talked about what it is. And that's what's going on. So this onCreate method is one that already exists within the Android system. And when the app runs, a bunch of stuff happens that we don't command it to. But what we're doing here is adding our own code to the onCreate method. And that's when you use override. So similarly down here, these methods already exist. We're just adding to them. So now we're finally at the stage where we can write our code that we want to run when the seekbar is moved. Just have a quick look at this method onProgressChanged. It returns 3 variables: the seekbar itself, so which seekbar has been moved; the progress integer, which is the number that we're particularly interested in, which is going to give us the value that we want, which is how far up or down the seekbar the user has left it. And then finally we get a true or false boolean from user, which tells us whether or not it was the user that changed seekbar, or maybe we wrote some code to update the seekbar, which we actually will a little bit later on. And then if it was our code that updated the seekbar value, then this boolean will be false. Okay, so let's now print that to the logs. We'll do that using log.I, so I for info, and then we'll call it seekbar value. And we want to know the value of this progress variable. There we go. And of course we want to add the log to our imports up there so that we can use it. All right, let's take a look. So we should now find that we have our seekbar, and when we drag it up and down, the value of the seekbar is displayed in the logs. And then what we want to see here is progress. But remember, progress is an integer, and when we send things to the logs, they need to be strings. So we can convert that to a string using integer.toString, and then the thing we want to convert to a string is progress. There we go. So we're now pretty much done, but if we try and run this, we will see an error. You can see I've got this red wiggly line, so something's going to go wrong if we try and run it. Let's just see what that error is, and then we'll fix it. There we go. So this class here is not abstract and does not override abstract method onStopTrackingTouch and in onSeekbarChangeListener. So what that means is, as I mentioned before, there are a couple of possibilities that can get us to this chunk of code here. Either the progress is changed, or the user has just taken their finger off and not changed anything, or the user has just started to change the seekbar. And what we need to do is implement methods for the other two possibilities, even though we're not actually going to be using them. So let's just do that now. So the first one is on start tracking touch. So it's all been imported for us. So if we wanted to know when the user started tracking on the seek bar, then we would write some code there, but we don't, so we can just leave that blank. And the other one, you may have seen it, is on stop tracking touch. There it is. So again, if we wanted to know when the user stopped tracking on the seek bar, then we could use that there. But notice this one doesn't give you the actual value. This is just a generic method for you to do something when they stop tracking on the seek bar. So really the one that we're interested in here is the on progress changed, because that gives you the value that we're interested in. Okay, so now we've given all the methods that are required for on seek bar change listener. You can see that the red wiggly line has gone away. So now we should find that when we run this, it will update the logs with the value of the seek bar. And it will in fact do that while the user is moving the seek bar. So whenever the seek bar is changed, that's when it will update the logs, not just when the user removes their finger from it. So let's just get those logs showing. And now if we jump over to the emulator, there we go. So you can see it's now showing the value, and it goes all the way up to 100 at the top. Fantastic. So that's how we work with our seek bar. Now it's a matter of integrating this with the volume of our sound. So to do this, we're going to need an audio manager, which allows us to interact with the Android audio system and change volume and things like that. So I'm going to create it up here. It's going to have a type of audio manager, and we'll call it audio manager. There we go. We need to import the class, and it's not doing that automatically. So I'll just add that manually. It's import android.media.audio manager. There we go. So now we've created our audio manager variable, and we can use it wherever we like. So in the setup of our app, we're going to want to do two things. We're going to want to establish the maximum volume of the phone that we're working with, and we want to establish the current volume. And then we'll use those to update the seek bar to start with. So first off, let's take our audio manager and set it up so that we can use it to work with the audio system on the phone that the app is running on. And we do this using get system service, and we get it from the context dot audio service. And this allows us to work, as I say, with the audio on our device. But we do need to cast this to the right type. So we want to cast it to audio manager, because that's the type of the variable that we have. So now we can use our audio manager to get information about the volume on the device at the moment, and then we can change that manually as well. So let's get, first of all, the maximum volume for our particular device. So it's going to be an integer. We'll call it max volume. And to get that, we use audio manager dot get stream max volume. There it is. And the stream that we want to get is audio manager dot stream music. So this is the generic stream for playing sound and music within your apps. So you may have seen there was another one there for alarms and phone volume, etc. But we're interested in essentially the media volume. So that gives us the max volume for the music stream within our app, which is what we're interested in. Next, we'll get the current volume. So I'll call it cur volume. And we get that in a very similar way. So audio manager dot get stream volume. There it is. So that just gets the current volume. And again, we'll get that from audio manager dot stream music. There we go. So now we know the maximum volume of our system and the current volume of our system. So we need to set the maximum volume of our system to be the maximum value of the seek bar, because we don't want them to be able to set the volume bigger than the maximum possible value. So let's do that. Once we've got our seek bar, we can then set the maximum. So our seek bar, remember, is called volume control. So it's volume control dot set max, and the max that we want to set is max volume. There we go. So now we've set the maximum. Remember, it was 100 by default, but now it's going to be set to whatever the maximum volume of our system is. And we're also going to set the current value. So volume control dot set progress. So it's called progress because it's kind of considered to be a progress bar. So if we want to set the current value, that's setting the progress, and we want to set that to the current volume. So if they've got the current volume at 70% of maximum, then that will set our seek bar to 70% of the way along. So that should set up our seek bar to work with the volume. So the only thing we need to add now is, instead of just printing to the logs, we want to actually change the volume. So we'll do that using Audio Manager dot set stream, where are we? Stream volume. There it is. And the stream that we want to set is, once again, Audio Manager dot stream music, and we want to set it to progress. And then you might be able to see there we need to add a flags variable, which is where we can give some more information if we want to, but we don't here. We just want to set the volume, so we just put a 0 there. All right. So hopefully that all makes sense. We've created an Audio Manager variable, which allows us to work with the volume and audio in general on our system. And we've worked out the maximum volume for the music stream and the current volume for the music stream being the audio within our app stream. And then we've set the seek bar maximum to the maximum volume of our system. We've set the seek bar value to the current volume of our system. And then we've changed it so when the user updates the seek bar, that will in turn update the stream volume. All right, let's check it out. So that's a good sign. First of all, you can see that the seek bar is not at 0, but it's around 70–80% there. So if I now just play that, there we go. So now if I crank it up, hopefully you can tell that that was louder. And if I take it right down here, there's no audio at all. So I'll just play it quietly, and then hopefully you can just about hear that. There we go. We are changing the volume in real time there. Fantastic. So now we've got our seek bar, which changes the volume. The last thing we're going to do in this video then is to create a new seek bar, which allows us to scrub or seek to particular points within our audio file. So here's a quick challenge for you. Can you create a second seek bar and give it a separate ID, and then create all the necessary methods for it, just like we did here? And for bonus points, see if you can set the maximum value of this seek bar to be the length of the audio file that we've created up here in mPlayer. So that we haven't seen how to do before. You can either Google it or try and figure it out from the possible methods within mPlayer. Can't do that bit, don't worry. But that first challenge, create a seek bar and set up all the methods for it, should be fairly straightforward. I'll give you a moment to do that. All right, here we go then. So over to activity main. So exactly as before, we'll take our seek bar and we'll drag it in. There it is. And I'll set the parent, end and start as before. And then seek bar 2 is not particularly instructive. So I'm going to call it scrubber. Scrubbing being the general name for something that allows you to go back and forth within an audio file. So there we go. We now have our scrubber. So let's go back over to our Java file. And I'm not going to copy and paste this time, just so that we can see all the code again. But let's start by, in fact, I'm going to hide all that code there. And let's start by finding our new seek bar. So let's create a variable I'll call scrubber, which will have a type of seek bar. And I'm going to find it by its ID, but I'll need to cast it as a seek bar. And then find view by ID, resources.id.scrubber. There it is. Now let's set the change listener. So scrubber.set on seek bar change listener. There it is. And then we're going to do that with a new on seek bar change listener. This time it's very kindly given us all of the methods that we need. Fabulous. I must have messed up the auto predict in some way to not get those last time. But it gave us the opportunity to type them out ourselves at least. And then what I'm going to do is, just to make sure that it's working, I'm going to get rid of the log command from the previous seek bar and then copy that in here. And we'll change this to scrubber value just so that we know the seek bar that we're getting the value of. And then the little bonus challenge was to set the maximum of our scrubber to the length of the audio file. And we do that using scrubber.setMax. So exactly like we did before. And then we're going to use mplayer. And if we just type dot afterwards, you can see it predicts get duration. That looks like it's going to be exactly what we want. So that's what I was hoping you might do to figure out how to get the length of our audio file, but really don't worry if you didn't find that. Okay, so we'll just run that and make sure that that's all connected up nicely. And we should of course find that we've now got a second seek bar with a maximum value equal to the duration of the audio file. And then when we move it up and down, we can see the location of the seek bar. So there we go, look. Fantastic. So it's quite a big one. There we go. We are lacking the small horizontal line there to show the limit of the seek bar. I'm not sure whether that's an error in my simulator or something to do with the height of that particular seek bar, but I'm not too worried about that. So now the tricky bit. We want to update this seek bar with the location of our audio file. And there are a couple of ways that we can do this, but the simplest is to use a timer. So we do that by creating a new timer. And let's let it add that automatically for us. So new timer, and we want to create a schedule at fixed rate. There we go. And then within this timer, we want to create a new timer task. There we go. It's done quite a bit of auto predicting for us there. And I'm just going to add in a couple of numbers to get rid of those errors, what all of this is doing. So it's 0 and 1000 is what we want. Okay, so what's going on here is we're creating a schedule at fixed rate, which means we're scheduling a certain task to be done at a fixed schedule. So in our case, every second. And that task is a new timer task, which is created with what's known as a runnable, which is essentially just a method which we run regularly, which is by default called run. And it's an override, as we've seen before, because we're adding to it rather than creating it. And then down here, these two numbers give us the number of seconds before this timer runs for the first time. So we want 0 seconds there because we don't need a delay before we want to start the timer. And then this is the number of milliseconds between successive calls to the timer. So basically all of this says run the code that we're going to run in here immediately and then every second. So that's what this whole chunk of code is doing. And what we want to do here is update our scrubber seek bar to show the location of the audio file. So we just use scrubber.set progress, just as before, and then to get the progress we use mplayer dot, and then you can see right there, get current position. Perfect. And that's it. So this timer will run every second and will update the value of our scrubber, or the progress of our seek bar, and show the current position of the audio file. Let's take a look. So if we now click play, make sure we've got some sound. There we go. So you can see it ran every second there. Because we've got a very short audio file, every second might not make sense. So let's just update that to every 10th of a second. And we should find that the update is a bit more smooth. There we go. So it'd be up to you in terms of how efficient you needed that to be in your particular case. But generally every second I would have thought would be fine. Normal media player app. Alright, so we're nearly there. What we don't have yet is the facility to actually scrub the music as we drag this back and forth. But that's pretty straightforward to add. So this, remember, is the code that is called when our scrubber is changed. So all we want to do is update the current position of the audio file. So we'll do that using mplayer and then seek to. There we go. So this will seek to a particular location or position, and that position, of course, we want to be progress, which is the value of the seek bar. All right, so with any luck, this should now do everything that we want and will allow the user to seek back and forth through the audio file as well as change the volume. Let's give it a go. So if I can grab that. There we go. It sounds pretty horrendous with our particular file, but it is in fact working. So here we go. Press play, and if I can grab that, there we go. So it sounds pretty horrendous with our particular audio file. And I think my emulator is struggling to keep up with all of that. And you might want to implement some kind of pause system, which I'll set as a little challenge here to do. You might just want to pause the audio when the user starts tracking and then restart it again when they stop tracking. And that will prevent that nasty effect of the audio playing during the seek. So just a little challenge there for you. And then we're going to take a brief break from audio before we make the final app of this section.